Hello everyone. We have seen a lot in the for loop, and I hope now you have got some clear and quite well understanding about how this first loop that we studied is none other than for loop works. Okay, now you understand, now you know how to write a for loop, how to do things with the for loop, and how the functional diagram or flowchart of the for loop works. Okay, so you can draw a flowchart of a for loop, or you can draw a diagram of a for loop without any issues now, and you can try to understand the workflow. You can understand the workflow of the for loop now. Okay, so I have said to already, normally in the for loop in Arduino, what we did, we mentioned int I, then I is equal to 0. So I'm just saying an example, it can be any value. I is less than or equal to 10, I plus plus, yes or no? So we did something like this. I'm sorry guys, where were I? Okay, we did something like this. Okay, so now here we do the declaration of the variable, here we do the initialization of the variable here. So I didn't write with Arduino, okay, but in some of the programming language, or most of the programming languages, we can do this both things here. That means anyway this I is going to be used only inside the for loop only, right? So if we do the declaration also inside the for loop, we are good, because the usage is only going to be inside the for loop, the I's usage, okay, because I is only used to iterate the for loop. So it is not must to have this separately here. If we declare it here, that also should be fine, because normally what we do sometimes when we declare and initialize a variable, we do it in one line sometimes. That is acceptable. So that one line declaration and initialization together we can do inside the for loop in some programming languages. Okay, with Arduino I didn't test it. If you want, you can give a try and see whether it works or not functionally. Okay, you have to either write the code like this and upload and test with the Arduino. Okay, and see whether the for loop works or not by testing with the real Arduino. Okay, you get it. Okay, anyway, for the moment I will keep it like this. Declaration and initialization is separate, but in Java and in other languages you can do this. Even C also I think you can do it. Okay, so that makes things easy, right? You don't have to write two lines, you can only write one line, that's enough, that's fine. So let's keep it this way. This is one point I have to say, and today we will study about the while loops. Okay, so when you study about the while loops, I'm just telling, writing while loop is somewhat similar to the workflow diagram of the for loop. You remember the workflow diagram of the for loop? I said you the initialization should happen first, then condition is inside the loop, and increment is in the last line. Okay, so but we cannot write like this, we have to write like this, but workflow is like that. So just visualize the workflow, and while loop is somewhat similar to the workflow, not 100% but somewhat. Okay, so let's see how to write the while loop. So while loop is very simple. You have to write while, and you have to open and close a bracket, and here you have to write your condition. You have to write what? Your condition. Okay, while condition. Okay, then you open a curly braces and you close a curly braces. Okay, okay, you open and close the curly braces. Okay, and whatever the actions you want to happen, you can write inside the, I'm sorry guys, while loop we have a right. Okay, action should be happening here. Okay, so while the condition and action. So what does it mean is, when the condition is true, the action will happen forever. That means action will happen. Okay, that means if this condition is evaluated to be true, okay, this while loop, the code will get into the while loop, somewhat similar to the for loop. Okay, get into the while loop, and then it will do the action, and it will come here, and like exactly like for loop, the program will come here and check whether this condition is still true or not. If the condition is still true, we will again do the same action. We will get into the while loop and do the action. Then again we will come and check here, right, where the condition is true or not. Okay, if it is true, we will do the action. We will get into the while loop and do the action, and we will come to the last line and again check. Okay, if it is still true, we will get into the while loop and do. By any moment, any time, okay, during some any time, okay, by any chance, in case if this condition become false during an iteration, let's say during one iteration, any iteration, it is true, we do this. Okay, and again we come here and again we come and check whether this is still true or not. During this time, if we find this condition is false, then immediately we will skip the while loop. That means the program will not get into the while loop, like breaking the for loop, right, like getting out of the for loop. The same way, the program will not get into the while loop if the condition is found to be true, and the program will immediately skip everything inside the while loop. That it will find, okay, this open and curly braces are the area of the while loop, right? Owners of the while loop owns only this area. So the program will come out of this, program will skip this whatever inside these two curly braces, and it will come to the next line and it will do whatever is written in the next line. Okay, the same like for loop, right? You get it? So this writing one condition inside that loop is somewhat similar to the for loop. Okay, so how do we make, okay, let's say something is let's say just what do you call something we have to make true for a particular number of time, and after that we have to make it false. How to do it? Now you can refer the for loop workflow diagram. Okay, in for loop what we did, we took that integer value in the on top. Okay, when we in for loop we write like this, but when we look at the flow, we take the initialization first before the loop, and we check the condition in the inside this condition checker, and we do the increment or decrement thing that is used to break the loop at one point. Because of this increment only, this loop is breaking at one point, isn't it? So that thing we write in the last line and study the flow, right? While loop is somewhat similar. You have to manually do those things. How? Let's say I'm going to check x is greater than 10. The same thing. Okay, sorry, I'm going to check x is less than or equal to 10. So I'm going to say, let's say I'm going to do the same thing here, right? I'm going to I'm willing to do 10 times of printing high. Okay, 10 times of printing high. Okay, so here you know what happens. So the okay, but here we cannot write everything here. Here we only have the condition, right? So what I will do is I will say I is less than or equal to 10. We will do the action, but we have to initialize and break that. Okay, I mean bringing it to the 10 times, and after 10 times the while loop has to be broken. That's the purpose, right? Only 10 times we have to print the hello. So what I will do is I will first declare and initialize a value to the I value. Okay, so int I is equal to 0, something that we have done here and here inside the for loop. Okay, then I will see, okay, I is equal to 0. Now I is less than 10. The action will be done. Okay, so next iteration code will not go here. Code will come and check whether this is true or not. Okay, still I is 0. Again it will do. Again we will come. Still I is 0. Again we will do. Okay, so what will happen? I is not incremented. So we don't have a way to break the for loop, while loop after 10. That means we don't have a way to increase the I value up to 10. So we have to do that. So how we will do it? So we manually write a line in the last line of after the action. We manually write I is equal to I plus 1. That means what? We increment by I by 1 in the last line. So that also we can write like I plus plus. Okay, now what will happen? This I initialization will happen. I is less than 10 means 0 is less than 10. Action will happen. I is incremented by 1. So the new I is now 1. So now when we check it, we don't go here because it's a loop. You will only check the condition. So the new I 1 is less than 10. So action will happen. Now I is incremented. New I is 2. Likewise, I will be incremented until it is 10. So when it is 10 also we will do it because we have the less than or equal. When I become 11, we will break the while loop and we will come out of the while loop because 11 is less than or equal to 10 is fake. Okay, and we will move to the next line. Okay, now you look at this. If you look at this flow, okay, if you look at this code, this is code. This is similar to the for loops workflow. Similar to the for loops workflow, right? Okay guys, it's almost 10 minutes. I will catch you up in the next video.